Welcome to Smalltalk Daily for Wednesday, May 13th, 2009. This morning I thought I'd go through a very simple little exercise. I have a file here and it's got 2 lines in it. And I've got a little bit of workspace code that reads a line at a time and stuffs the results in a collection. Not terribly exciting. I'll show you how this works. Let's just highlight all this, do an inspect. And there you see the lines in my ordered collection. Not exciting. However, let's say that what you wanted to do is make sure that when you're reading the file, if anything happens, like you get an operating system level error, you get a Smalltalk exception, you get anything like that, you want to make sure that the file is closed. You don't want to leave that operating system resource hanging. So this is the same kind of code is appropriate for reading sockets, for reading files, for reading anything, where you're less interested in handling the exception at this point in code than you are in just making sure the right thing happens and the resource gets managed. So here I've introduced a simulated error by misspelling ADF:, and I've just got the same exact code. So what you're going to see happen is, I'm going to do this inspect again. I'm going to ignore the warning that this is a new message, and then it's going to give me this. ADF: is not understood, of course. However, here's the problem. I've got access to the stream because I'm in a workspace, but if I inspect it and then send closed to it, which is a test message, notice what it's going to tell me. It's going to tell me that it's not closed. Now it turns out that since I'm in a workspace, I can handle that pretty easily just by going ahead and executing this line of code here. But depending on how your code is structured and where this happens in an actual runtime system, that may not be as easy. You could be leaving an operating system resource hanging, and on some platforms this can be more troublesome than on others. You know, on Unix you might run out of file handles. On Windows you could run into file permission problems. So there are various reasons you don't want to do this. And here's one simple way of dealing with the problem. What you do is you wrap your entire block of code that is dealing with the stream in an ensure block and say ensure, and then put this close in here. So with this structure, this stream close code in the block will fire regardless of what happens with the exception. So the stack unwinds, this will fire. So let's see what happens here. We'll execute the same code, and we're going to get the same exception. So you see I've got the same exception. But let's leave that up and go ahead and inspect this stream object and send our test message to it again. So what we'll do now is we'll send closed to the stream and see what happens. And you notice here it says it's closed. So what's happened is, even though I've got the exception, the code in my ensure block fired. So this is a way of ensuring that something like an operating system resource or some other critical thing in your code happens regardless of what kinds of exceptions are fired. So let's go ahead and look up ensure in the system and take a look at how that's implemented. So let's go ahead and browse implementers of ensure : and you see here in block closure, notice the comment, evaluate the receiver and answer its result immediately after successful, but before returning its result, evaluate the termination block. If it's abnormally terminated, evaluate it anyway. So this will happen regardless of what else goes on. So it's a way of making sure that something that you want to have happen in all cases happens. So that's about it for today. Until next time, have fun with Smalltalk.